Yeah, it can hear you talking. It's fantastic. It's amazing. It can't see you though. It can hear you. And that just got recorded. So we'll get to listen to that. That's fun. Alright guys, number one, we are going to look at a pie chart. And you're going to have to just interpret a pie chart. Okay? So, you're going to interpret a pie chart. That sounds easy, right? For number two, you're going to interpret a bar graph. Alright. And we're talking about, we're calling it a bar graph, right? Because probably it's dealing with categorical variables and not quantitative, right? Cool. Or qualitative. I know you guys are used to hearing that as well, but we're going to call them categorical. All right, for number three. Given data, describe how you would make a stem plot. So look over those stem plots, all right? For number four, you should understand, and we'll talk about it a little more during the review. Understand how skewness it is a word, affects the mean and median of a distribution. Hey, there we go. Hey, we got through 4 questions. It's pretty amazing. All right. So far, it doesn't look too bad. All right. All right, let's look at number 5. All right, so given a stem plot, match a corresponding did I spell it right? No. Oh, see, I knew it. Yeah, I knew there was a double in there somewhere. That's why Dorman's not your English teacher.
Yeah. C-O-R-R-E-S.
There we go. See? It's in there. Sorry. Match a corresponding. The thing is, I'm thinking about math and not English. And it's spell check ruined me. During college, I never had to think about the way a word was spelled. I just had to hammer keys. Right? Okay. And match a corresponding box plot. Okay. Okay, if we look at a two-way table, so you're going to have to interpret A to A. So look that bad boy up in your book. So I would highly recommend that you have your books tonight, right? Take those home. Okay. Yes, and don't forget to look at the calendar, right? It's on your calendar for AP Stat. I'm gonna Google Calendar. All right. So you also need to understand how does adding a data point to a distribution affect the mean and mean? Be able to answer that question, right? So if I have a data set and I add a really big number or a number that's kind of in between, right? If I was to add a really big number, it's going to push all that stuff. It would push everything depending on the way that it's going to move it in the direction of that value, right? If you were to add a really small value, it's going to push your mean and your median in the direction of that value. But if it's extreme, your mean and your median are actually going to separate. They're not going to be as close together. Those values won't be as close together. All right. And we'll have time for a little game. A little something that'll help you actually review some of that knowledge. All right. All right. So we're going to interpret mean in context. So just understand what your mean is in context, right? So if you're given two different data sets that contain two different means, explain how they're related if we're talking about the same variable. I'm going to give you a cool little matching game. It's going to really help out with that. What's up? No, it's actually with real paper. I'll get it out here in a second. Hey, be able to correctly define standard deviation. And you should always be able to do this. In this case, it's actually in context. Right, the standard deviation is the average difference each data point is from the mean, right? And so you'll have to actually, you'll have a contextual situation, and you'll have to interpret that definition in context. Number 10. Be able to interpret. A 5-number summary. 5-number summary, remember, it's what you get your values in a box plot from. Your 5-number summary is your max. Quartile 1. Median. Quartile 3. And your, wow, did I really do that? I did. Too many M words. How about min? Min belongs over here, right? Your minimum? Yeah. And remember that each one of those are obtained by splitting your data set into quarters, right? So split it into half and then split your halves into halves. And you have all of those numbers. Right? When you split it in half, the number in the middle is your median. When you split all the stuff down below your median in half, the number in the middle is quartile 1. And the same thing corresponds with all of the data above your median. You can split that in half. The middle is quartile 3. And of course, maximum and minimum really don't require explanation. So, fantastic. It's you're on number 11. Come to the pre-response section. Excellent. Not hard if you're not daft. Okay. So, I do really love that word. I never get the chance to use it though.
Do you like trap or how to train your dragon or something?
Gosh, I should have. I really missed my calling there. All right. All right. So, I almost read the question just now. That would have been clever because it's being recorded. Watch, I'm gonna. I just saw the answer. Okay. Okay, so we're going to be given dot plots. We're going to have to determine if there are outliers, and then draw box plots for the 2 dot plots. Okay, so this is going to happen. Given a dot plot. Determine if there are outliers. And then once you're done with that, you're going to have to be able to create a box plot from a dot plot. Hey y'all, hey, make sure guys, whenever you're making any graph of any sort, right, make sure that you are labeling things, right? Every graph deserves a title, right? And it needs to have its axes labeled as well. It actually reminds you of it on question 12. It actually tells you, which is really nice of them, because they don't tell you that on the AP exam. They just take points off, right, if you don't label stuff like that. So, okay. All right, for 12, you must construct a histogram and decide if standard deviation or mean. Oh, it's not standard deviation. Good grief. My bad. No, measure straight. If. Yeah, it was supposed to be if. Sometimes my brain doesn't match right. It's okay. Oh no. I'm not decided about, but decide the most appropriate. Measure of spread. So definitely look at different measures of spread. And then for 13. Understand conditional distribution. It sounds way more complicated than it is. From a two-way table. So the idea is, right, you have a two-way table, it's got a bunch of values, right? It says, if male, if female, if they don't, then if they don't like candy or they do like candy, right? And they have the total amount of people, you know what I mean, from the two-way table. And what this conditional distribution is going to be, hey, we only want to look at people that like candy, right? So you're going to eliminate a bunch of people. You're going to eliminate all the people from the table or all the data from the table that pertains to people that don't like candy. I just said we're looking at people that like candy, right? Okay, fantastic. Trying to keep that together in my head. Yeah, so that's essentially what you're going to be doing with that. It's actually, this terminology makes it sound much harder than it is. All right. And then you're going to then just interpret those conditional distributions, right? Okay. This one I didn't actually really talk about too much here. It's in the text. It's really actually, it's, as I said, it sounds more complicated than it is. It's not bad at all. You guys have any questions about this? No? Okay, I'm gonna get a cool activity together for you. All right, thanks. That's enough.